All right, in this problem we have the greatest integer function, which is defined by the greatest whole number less than or equal to x. Okay, so it says calculate these two limits. The limit as x approaches 2 from the right of the greatest integer function and from the left. Okay, and then we're going to look at continuity, but first we'll need to look at those limits. So, okay, for the limit as x approaches 2 from the left and right, I think it'll be helpful to sketch a graph of the greatest integer function here. Okay, so let's make it a little bit large. There's 1, 2, 3. That should be good. 1, 2, and 3. Okay. So if x is, for example, 0.2, right, maybe right in here, the greatest integer of x is the greatest whole number less than or equal to 0.2, which is 0, or even 0.9. The greatest whole number less than or equal to 0.9 is 0. So, and at 0, the greatest whole number less than or equal to 0 is 0. So the y value at all of those decimals is 0. Now the greatest whole number less than or equal to 1 is actually 1. So right when you get to 1, it jumps up. Okay, then for all the decimals between 1 and 2, 1.2, 1.5, right, all of those, the greatest whole number less than or equal to any 1 point something is 1. So we always round down right up until we get right at 2, and then the greatest whole number less than or equal to 2 is 2. Okay, so once you get the pattern established, it's pretty easy to sketch the graph, and you can actually keep going through negative numbers that way too if you want. Okay, so to find the limits then, the limit as x approaches 2 from the right. So here's 2, go over to the right side of 2, up to the function. Okay, as we get closer and closer and closer to 2, those y values are at 2. So the limit as we approach 2 from the right would be 2. Or as we approach 2 from the left, that would put us over here. Those y values are all at 1. They're approaching 1, but they're actually at 1. Okay, so the function is considered right continuous at 2 because the limit as x approaches 2 from the right of the greatest integer function happens to equal f of 2. It's because you have that closed dot right there as you approach. The y value equals the limit from the right. The y value does not equal the limit from the left, so it's not left continuous. The function's not continuous, not just regular, continuous at 2 because it's got a jump discontinuity there. Yep, so that is the greatest integer function and limits and continuity.